Okay. We'll be doing okay, okay. Let's start. All right. Today we will be doing Newton's second law, and I'll be like helping students with questions based on Newton's second law. So okay, let's start with our question one. So an 8 kg block is connected to a 4 kg block by means of light inextensible string. A constant force of 55 newtons is applied to the 8 kg block to accelerate the combination of blocks to the right. So okay, there is our diagram of 4 kg block on our inclined surface and our 8 kg block on our horizontal surface. Okay, and 55 newtons is applied to like accelerate the combination of blocks to the right, which means the combination of blocks is going to the right. Okay, so let's go to our statement down below, which says kinetic force between the 4 kg block and the inclined plane is 4 newtons, while the kinetic force between the 8 kg block and the horizontal plane is 8 newtons. Okay, yeah, it's not placed here. It's not placed. It's actually plain. Okay, it's plain. Okay, so all right. So okay, let's go to our first question, which says define Newton's second law. Okay, so okay, our Newton's second law definition is okay, let me zoom in a little bit. When a non-zero resultant or net force acts on an object, the object will accelerate in the direction of the net force, and the acceleration is directly proportional. Okay, okay, let's start. When a non-zero resultant or net force acts on an object, the object will accelerate in the direction of the net force, and the acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Okay, so okay, this definition basically tells us about this formula F net, which is equals to m multiplied by a, which is mass multiplied by acceleration. So okay, when it says our acceleration is directly proportional to our net force, it basically means that when our acceleration increases, our F net also increases, and when our acceleration decreases, our F net also decreases. So okay, do you understand it? So okay, let's go to inversely proportional. Okay, let's go to when our acceleration becomes inversely proportional to the mass of an object. Okay, let me explain like what it means. Let me explain what it means. What it means is that when our acceleration, okay, here it is. When our acceleration, okay, increases, our mass decreases. So when our acceleration decreases, our mass increases. That's what it means, inversely proportional. That's what it means when they say acceleration is inversely proportional to our mass of our object. And when they say acceleration is directly proportional to our F net, it just basically means that when acceleration increases, it means that your F net also increases. When it decreases also. So okay, let's go to our second question, which says like draw your free body diagram on our 4 kg block. So okay, let's go back to our system. So okay, you can see our 4 kg block is on an incline. That angle represents inclination. It shows that the surface on which our block is placed is on an incline, like it's lifted. It's not on a horizontal surface. It's not really horizontal, like the plane is not horizontal, it's inclined. So okay, So okay, they are saying we should draw free body diagram, on our 4 kg block. So okay, all right, okay, let me charge my cell phone, like it's on a low battery. Yeah, but okay, let's go. Okay, and we're on our free body diagram of our 4 kg block. So okay, you can see our 4 kg block, and don't forget that the forces that act on our object, mostly when you find like okay, a block is placed on a plane or something, the force that are being exerted on our block, you know what I mean. So you don't forget that we have a normal force, we have a frictional force, we have a force applied, we have a gravitational force, we have um, tensional force. Yeah, those forces, you should always remember them. Don't forget them. Don't forget them. So okay, they want us to draw our free body diagram on our 4 kg block. So okay, let's go. This is how we do it. Um, I don't know if how should I place my phone so that you can see, everything, because all right, okay. Um, our 4 kg block is placed on our inclined plane, so which means our normal force will always be perpendicular to the plane, is always perpendicular to the plane, regardless of the position our plane is at, you know like, but always our normal force is always perpendicular to the plane, the plane we're talking about, the surface on which our block is placed, this plane. So okay, which means our normal force will be perpendicular to our plane. That's how you draw your free body diagram. It will be perpendicular to our plane. This is our normal force. So okay, we also have our gravitational force. Our gravitational force is always exerted downward. This is our FG, gravitational force. This is our FG. So okay, all right, okay. This is our FG. It's always exerted downward. So okay, we also have this string here, this string here, which means that this string here, okay, is connected between, it is connected, okay, it is connected between, okay, it connects these two blocks. Let me put it that way. It connects these two blocks, which means the tension here is available. There is a tensional force here, there is a tensional force here, tensional force. So okay, let's go. So which means okay, the tension force, because um our 4 kg block is being pulled this way to the right, it means also our tension on our 4 kg block will act to the right, like the arrow will go to the right, but not really right to the direction of our applied force, because you can see that our 4 kg block is on an incline, which means that our tensional force will be parallel to our inclined surface, inclined plane, will be parallel to our inclined plane, because our block is on an inclined plane. So okay, and it is also said that our kinetic force between our 4 kg block and the inclined plane is 4 newtons, which means there is also a frictional force that is acting on our block. And always the frictional force is always opposite to our motion. You know, where the block is going, the frictional force opposes that direction. You get me? It always opposes that direction. So okay, so here's our free body diagram on our 4 kg block. So okay, we're done here. So okay, let's get to the questions. Let's get to the questions, the calculations. We are done here. We're done here. We're done here. Let's get to the questions. Let's get to the questions. Okay. So here, okay, we are still on our on that creation of our 8 kg block and 4 kg block. So okay, here they're saying calculate tension in the string connecting the two blocks. So okay, when you deal with the calculations in physics, when you deal with the calculations, more especially when it comes to these things of concerning our forces, like always draw your diagrams on your rough sketches, because the things that you are going to do on these sketches, that these are things you can't do on your free body diagrams. You get me? These are the things that you cannot do to your free body diagrams. So okay, on your free body diagrams, and I forgot something. On a free body diagrams, on our free body diagrams, they are saying, okay, sometimes they always allocate marks. They'll say, draw free body diagram of which block, of which system, and then they'll ask you, actually, when they allocate you marks, they are saying that there are so and so forces that are acting on that block. If they give you they allocate, okay, 4 marks or 5 marks, they are saying, okay, there is 4 forces that are acting on that block, or 5 forces that are acting on that block. So now just always don't forget the forces about normal force, force of gravity, gravitational force here, force applied, the tensional force, the frictional forces. Don't forget those forces. So here on our 4 kg block, we have 4 forces that are acting on our 4 kg block, which means it was 4 marks. Normal force, tensional force, gravitational force, and frictional force, FK, because the object was moving, was being pulled. So FK just represent kinetic frictional force, because it's moving. If it was maybe static, at rest, you was gonna say maybe FS, like static frictional force, or one. So okay, let's go to our questions. So okay, calculate tension in the string connecting the two blocks. So okay, already we have our 4 kg block. Okay, this is our free body diagram on our 4 kg block, and you can see now we have components. On our 4 kg block, and these components we didn't draw them on our free body diagram as questions, because they were not required. They are not needed. They are not necessarily needed. We mostly do this when we want to work on the questions. So that's why I'm saying, always draw these free body diagrams on your rough sketches when dealing with calculations, so that you know which steps to follow, which forces to use, things such as that. So okay, now we drew our free body diagram on our 8 kg block. and all the forces that are acting on our 8 kg block. And don't forget, our 8 kg block is on our horizontal surface. You can see our 8 kg block is on our horizontal surface. It's not on our inclined surface. It's not on our inclined plane. It's on our horizontal surface. Horizontal surface. So okay. So you'll see the difference between these three body diagrams. Okay, you can see our 4 kg block has our components only because the surface this block was on, it was inclined. So okay, our 8 kg block doesn't have the components forces, you know what I mean, doesn't have the component forces because it was on our horizontal plane, not on our inclined plane. So okay, they are saying calculate tension in the string connecting the two blocks. All right, all right, all right, all right, all right. Let's go, let's go, let's go. Stay with me. Don't get lost, guys. Stay with me, okay? So on our 4 kg block, okay, you know, the force on our Newton's laws, our Newton's laws force on our Newton's second law. The formula. F net is equals to ma. F net just represent the um the sum of all forces that are acting either on our horizontal plane or on our vertical direction. Let me just put it that way, on our horizontal direction or on our vertical direction. So okay, it's just the sum. F net is just the sum of forces. So m represent the mass of our object. So then the acceleration is the rate of change of velocity. So okay, let's go, let's go, let's go, let's go. Okay, we know that our system is going to the right. So okay, so before you attempt the question, you before you place in the forces on our formula. So just first determine the direction you wanna use as positive. The direction you wanna use as positive. I always tell the students to, like, okay, just use the direction in which the system is going as positive. You feel me? Always use the direction in which the force is going as positive. So then the forces that are opposing the motion, they will all be negatives. You understand? So okay, let's go. But even if I'm wrong, guys, you can correct me. I'm not I'm here to learn also. So yeah, I'm here to learn also. So yeah, it's just that I've done this before. So okay, yeah, let's help one another. So all right, all right, all right, all right, let's go, let's go, let's go. Okay, our system is going to the right. So okay, what's taking all the forces going to the right? Forces that are following the motion, you know, as positive. Bonsoir. The forces that are opposing the motion, they will all be negatives. Bonsoir. So okay, on our 4 kg block, we have our ft, ne? We have our ft, ne? It's going to the right. It is going where the system is going. So you will take it and place it here. It will be as your positive. It will act as your positive. It will act as your positive. So okay. And okay. And here's the thing. So okay. Okay, excuse. So okay, our 4 kg block, remember that it was on an incline, and only our gravitational force, okay, sorry for the hand, and only our gravitational force does not change. It is only our gravitational force that does not change directions. It is always going downward, downward, downward. It is always acting downward. So our FG will then have the components, the components, the components. You know what I mean? Okay, look, our 4 kg block um was on an incline, eh? So, and our block was here, eh? And the forces that are acting on our 4 kg block are either parallel or perpendicular to our surface. Do you get me? Are either perpendicular or parallel to that surface, but our FG is the only force that then opposes that principle. It is our FG that opposes this principle. You know what I mean? Of either being perpendicular or parallel to the surface. So because there was an inclined plane here and our gravitational force is acting downward, is not acting perpendicular or parallel to our inclined surface. So then we'll always need to like find the components of our FG. So then, which means we'll have FG parallel, which means the force that is parallel, it means that this force is parallel to our surface now. You know, it is parallel to our surface. So then we'll also have the FG perpendicular, which means this force is now perpendicular to the surface. So these forces, they follow the principle of either being perpendicular or parallel to the surface, which means we'll use these forces and not this one alone. We'll use the forces that follow the principle of either being perpendicular or parallel to the surface. So then our angle value will have to be here. Okay, yeah, okay, let's come to this one. Our angle will have to be here because our 90 degrees is where these components match. You know, it's where these components match. Sorry for the end, guys. But I don't know what, guys. Will be I don't worry, will improve because now I'm just using my phone and I don't have a board here. I'm just using a phone. I don't have a board yet. But then, okay, let's go. Okay. So then it means now we'll use these forces, the FG parallel and the FG perpendicular, because they are now following our principle of either perpendicular or parallel to the surface. So okay, we said we'll take all the forces going on our direction as positive and all the forces that are opposing our direction as negative. So we have FT. FT will be positive. One is FT will be positive. So then okay, these plus, they just represent the sum of all these forces. It's F net. They just represent the sum of all these forces. We are not yet like using the direction of our negatives in our what they're just the sum of one. So then okay, we have ma, mass multiplied by acceleration. Okay, so our ft is okay, it's positive value. So okay, our fg parallel, okay, here's our fg parallel and it's acting opposites. Okay, here's a thing in okay, it will go this way and this one FG perpendicular will go downward. So okay, so here's why we say that our FG parallel is negative. Now we're working on our horizontal forces. We are not using a vertical forces. We are not using the forces that are acting on our vertical, because here we're not yet looking for our normal forces or whatever forces that is acting perpendicular to the surface. So okay, FG parallel, okay, I get it. Okay, you see our angle is placed on top, and then our 90 degrees is here at the corner where our FG parallel and FG perpendicular merge. Yeah? So okay, just flip your script so that you can see your right angled triangle. Now you can see your right angled triangle. You can see your right angled triangle. So okay, now you can see your right angled triangle, ne? And then we have FG perpendicular, which is acting on our adjacent side. Now it is on our adjacent side. So then we have our FG parallel. FG parallel is also opposite to our hypotenuse. Hypotenuse is our FG. You can see it. It's our FG, and then this FG perpendicular is our adjacent side, which is adjacent to our hypotenuse. But no, we are not looking for this one. We are looking for our FG parallel, which is opposite to our hypotenuse or our angle. So okay, okay, let me do this. Okay, so let's use our trigonometric ratios that we used on mathematics, which is cos. Okay, again, already have our angle, which is 30 degrees, is equal to our adjacent, which is FG perpendicular over FG, which is our hypotenuse. So okay, we'll do cross multiplication, which is FG cos 30 multiplied by FG is FG cos 30 degrees, which is equal to 1 multiplied by FG perpendicular is equal to FG perpendicular. Don't forget, any number multiplied by 1 or anything multiplied by 1 is equal to that thing. So then we have our formula for FG perpendicular now. So okay, let's look for our FG. So okay, you can also do the same with our FG parallel, which will be sine. Our FG parallel is sine because it is opposite to our angle. It will be sine 30, which is equal to FG parallel over FG, which is our hypotenuse, and then you do the cross multiplication, and then you are left with then FG parallel is equal to FG sine 80. You feel me? So you already have the formula for FG parallel. So okay, I was just showing you the trigonometric ratios on how to like tackle these questions. Yes. So okay, so all right, and don't forget that we don't have FG. We don't have FG, but FG, we can find FG. FG is equals to mg, which is mass multiplied by the force of gravity, which is 9.8 meters per second squared. So okay, here we are now. So okay, Ft, we said it is positive because it is going to our direction. So then we have our FG parallel. Our FG parallel, we said, is FG sine 30. So okay, here I just didn't write the 30 here. I just wrote my thinking like just yeah, something that will represent something on top. So okay, so okay, it was FG sine 30. So okay, FG, we said we don't have FG. We don't have FG. We don't have FG. But we can find FG using this formula. So okay, instead of FG, I just replaced it with mg. Then sine theta ne, then minus fk. These are all negatives because they oppose our motion. They are going in our opposite direction. They are not going to the right, they are going to the left. So okay, so okay, we'll say okay, as I've explained here, is mg sine theta. So then ft is always positive. We don't have ft, we are looking for ft, which is our tension. So okay, minus because it's going to the left. Okay, instead of m, we're going to write 4 because we're working on our 4 kg block. So our mass is 4. Ne? So then on our g, force of gravity is 9.8. We're going to replace it with 9.8. So then will be sine. So then instead of okay, like it was not really necessary for me to write this symbol here. I should have, or I should have just wrote, I should have just used the 30 degrees instead. So okay, but it's fine anyway. So okay, it's fine anyway. Here I've written them. So okay, minus 4 because we were given our frictional force which was acting between our 4 kg block and our in our inclined plane, which was 4 newtons. So okay, we have 4. So then mass, on our mass, because we're working on our 4 kg block, you're always going to write the 4 where there is mass. So okay, we don't have acceleration. We don't have acceleration. Okay, so then we worked out on okay, FC, we don't have him, but then punch in our calculator in order to find our 23.6 newtons. Okay, yeah, you don't have to write okay newtons, but okay, yeah, it's our forces that are acting here. But then yeah, it's our newtons. But then okay, just 4 multiplied by 9.8 multiplied by sin theta minus 4, it gave us 23 comma 6. Yeah, 23.6. And when you add these numbers, don't leave out this negative, just say negative and then you say 4 multiplied by 9.8 sine theta minus 4, and then it will give you minus 23.6. so it's equals to 4a. Our a is acceleration. It's not 49, guys. It's just 4a. So and then we have our equation number 1 because we didn't find our ft here, and we have 2 unknown variables, which is our ft and our 4a. So okay, let's go and borrow some friends from our 8 kg block, because we didn't find our FC on our 4 kg block. So now let's go on our 4 kg block. Now we are going to work out these simultaneously. Yeah, it's like simultaneous. You know what I mean? It's like simultaneous. So okay, on our 4 kg block, don't forget that this thing was horizontal. Like guys, name. Because now I'm just doing videos here. When doing this question, just make sure that you draw the first diagram. I mean this diagram with our 55 newtons here. Just draw it as well, and then draw your this free body diagram, so that you, when doing these questions, you are not disturbed or anything. Just follow them so that you are not disturbed, you don't get confused or anything. Just always do it like that, because now guys, I'm just making a video here, and I've already done this because I was tutoring some students. You know what I mean? So yeah, I was helping them with Newton's second law. So yeah, so these ones I'm just revisiting them, like to so that I can help the other students in order to understand these things. Okay, let's go. We're on our 8 kg block, so our 8 kg block, don't forget I said, like, when you watch this video, make sure that you draw that diagram with 55 newtons that I've showed you, and all these free body diagrams on your rough sketches, so that you can understand, so that you can follow me. Or when I say, because I can't always be like flipping the pages like that on our, you see, like, it will also help you, like, to understand the system, when you draw, you know what I mean, and do these questions as well. It'll also help you, like, to grab the procedure. So okay, on our 8 kg block, it's on our horizontal. So okay, on our 8 kg block, don't forget that we have our force applied. On our 4 kg block, like, the force that is used to pull the combination of blocks, the system, was used pulling our 8 kg block. Hence we say force applied is acting on our 8 kg block now. You know what I mean? So okay, and on our 4 kg block, it was just FT, the cable. You know what I mean? So now on our 8 kg block, it's our force applied, the 55 newtons. You know what I mean? So okay, when we draw the free body diagram on our 8 kg block, just always know that I said the normal force is always perpendicular to the surface, and don't forget that on our 8 kg block, the 8 kg block was placed horizontally, so on our horizontal surface. It was on our horizontal surface. Let me put it that way. It was on our horizontal surface, which means your normal force will be perpendicular to the surface. It will be perpendicular to the surface on which our block is placed. So then our FG now is following the principle of either perpendicular or parallel to the surface, because it is now perpendicular to our what? Our surface. You can see that. So okay, our FA is parallel to our surface. Yes, it is following the principle. Our FK, which is our frictional force, our kinetic frictional force, which is parallel to our surface, it is following the principle. And we also have our uh, tensional force, which is following our principle, because it is parallel to our surface. And look at this thing, the direction of our tension here on our 8 kg block. On our 8 kg block. On our 8 kg block. And don't remember, because it is a string, they're just pulling one another. Like 8 kg is pulling 4 kg block upward, which means the force that is going to act on our 4 kg block will on our 8 kg block for kinetic friction will go to our opposite direction. It will oppose the motion. Because the 8 kg block, it is pulling another object. You know what I mean? It is like 8 kg block, it is pulling 4 kg block upward using the tension force. You know what I mean? So it is the force that is being used to pull the 4 kg block upward. You know what I mean? So, and remember, our 4 kg block, it is always trying to pull 8 kg block downward, because it is on our incline. But you can see that the masses are not equal. 4 kg is smaller than 8 kg, so which means our 8 kg block will always have power over our 4 kg block, because the only force that is acting on our 4 kg block, it is our FT. the tensional force, which is pulling 4 kg upward. You know what I mean? So the force that is acting on our 8 kg block is 55 newtons, which means, and they say that the block is accelerating to the right. You know what I mean? And we already have the forces which are given, which the frictional forces, they are already there, is 4 newtons, and we also have the frictional force acting on our 8 kg block, which means that the block is already in motion. It's already in motion. You know what I mean? So okay, let's go on our 8 kg block, which is F net is equals to ma. So F net, as I've already said, is the sum of forces either on our horizontal plane or on our vertical plane. So okay, on our 8 kg block we have our force applied. Force applied is already there, it was given already. So I said always take the direction in which the block or maybe the system is taken as positive. You know what I mean? So okay, our force applied is on our positive direction, which means it will be positive force applied. So as I've said these pluses because I have not placed in the values yet. You know what I mean? I have not placed the values yet. These plus they just represent the sum of our forces acting on our horizontal plane. We're looking on our horizontal plane now, guys, not on our vertical plane. We're just looking on our horizontal plane because the forces that we are looking for are on our horizontal plane. If maybe we're looking for forces on our vertical plane, yeah, was going to use the forces on our vertical planes, but now the forces we are looking for are on our horizontal plane. So okay, we have our force applied, then plus Ft plus the sum. Don't forget that it's just the sum of forces. We are not like using direction yet. We are not using the direction yet. We are not determining the directions. Okay, which is equal to ma. So okay, we already have the forces that are acting on our okay, already have the value for our force applied, which was 55. So then now we're taking the directions now. The negatives, you can see the negatives. We are using the directions now. Okay, our Fc on our 8 kg block is opposing the direction. We said this direction is positive, and then the other direction will be negative. So okay, our force applied, we are given the value already, is positive 55. So then it will be negative Ft. Ft, we don't have the value of it. We are looking for that value. So okay, our kinetic friction. Don't forget the statement, guys. Kinetic force between 4 kg block and the inclined plane is 4 newtons, while the kinetic force between the 8 kg block and the horizontal plane is 8 newtons. So don't forget that. So okay, on our kinetic frictional force, we'll say negative 8. It's negative because it is opposing the motion. So it's equals to our in place of m, we'll place 8 because we are working on our 8 kg block. And look, guys, here we don't have the components because nothing is on a incline. We don't have the components. You only use the components when either the force is on an incline or maybe the object is on an incline, you know, because mostly we use FG to find the components when the object is on our incline, or sometimes you'll find they'll say maybe the force is acting on an incline of whatever angle, and then that's when you only need to use like the components because the system needs to follow the principle of either perpendicular or parallel to the surface. The forces, you only use the forces that are parallel or perpendicular to the surface. That's why we always need to find the components when we are given system with inclined forces. You know what I mean? Or inclined object. So okay, we have 55. Okay, direction value ft is opposing the motion and kinetic friction is opposing the motion. So then in place of m we'll place 8 newtons. So we don't have acceleration, we don't have acceleration, we don't have acceleration. So okay, because we have two unknown variables, so okay, and we have one constant number, so now we have our second 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 equation, eh? So okay, so now that we have our first equation and our second equation, we can use the elimination method. The elimination method, you just say equation number 1 plus equation number 2. So here you're basically saying these, they'll cancel. Ft, because there is plus multiplied by negative, which is negative, they automatically cancel. Ft cancel. Well, let me just, yes, let's kill these ones, they cancel. It will be ft minus ft basically. So it's ft minus ft, they cancel. One, they cancel. This is the elimination method. Yes, not formula. Okay, method. So okay, you will say negative 23,6 plus 47. You know what I mean? Minus 23,6 plus 47, which is 23,4. 23,4. So then you say 4 plus 8, which is what? 12. And it's 12 what? 12 8. These are like terms. Don't forget. These are like terms. 4a plus 8a. So they will add. It will be 12a. We only add the numbers. 4 plus 8 is 12. So then you just place a there. So then you just divide 12 over 12, and then you divide this number 23,4 divided by 12, and then you find your acceleration, which is 1,95 meters per second squared. There you found your acceleration. So and then again, now you find your acceleration. So and then choose any equation between equation 1 and equation 2, and then substitute your a on either the equations, like between these equations, like choose one and then substitute a in one of these equations. So okay, here's how I did it. Okay, I took our equation 1, which is ft minus 23,6, which is equals to 4a, and then ft minus 23,6 is equals to 4. In place of a, I placed 1,95, our acceleration. So then we found 31,40 newtons to the left. What? Yeah, it's okay. But here they just said, okay, just calculate the tension there. The tension, calculating the two blocks. You don't have to say to the left or to the right or whatever. Yes, you don't have